there, and welcome to another college math video. In this video, we're going to look at subsets, proper subsets, and kind of what that means within a problem. So here are our objectives for this video. We're going to learn the properties of subsets. There'll be a few definitions just to kind of lay down the framework. We'll list subsets of a given set, and then we'll find the number of subsets of a given set. So subsets are a way to take a set of information and potentially break it down into maybe smaller groupings. Okay, so two definitions that we're going to list here. The first one is for subset, the basic. So the definition, set A is a subset of set B. And this is what it would look like symbolically. If and only if all elements of set A are also elements of set B. So for a subset, we'll have one specific set, set A, or set B, and for set A to be a subset of that, all the elements that are in set B have to also be in set A. So a subset could be, you can think of a subset as sort of taking, maybe you have 5 different pieces of candy and you're trying to decide if you want to hand them out or not and how you would want to hand them out. Not necessarily to who, but how you would want to hand them out. So one way you could break down handing out those pieces of candy is that you could hand out none of them, you could hand out all of them, you could hand out one, and it could be this, or this. So for it to be a subset, it's a smaller grouping or also potentially handing out all of the pieces of candy. All right, then we have a more specific version, which is a proper subset. This definition sounds very similar. Proper subset definition, set A is a proper subset of set B, and this is what it would look like symbolically. Looks kind of like a C, but it's more of a sideways U. If and only if all elements of A are elements of B, so far, it's the same definition as subset, but with proper subset, we have one additional component, and set A is not equal to set B. So it's the same idea that you have 5 pieces of candy and you're wanting to hand them out in some way, shape, or form. Subset could be any version of handing them out. None, all, any mixture in between. A proper subset is a smaller grouping. So proper subset is technically just not handing out all of the candies. For proper subset, it could be just one candy, it could be none, could be 2, and any of the 2. So this is the differentiation between those two. All right. So let's look at some examples of deciding if something is a subset or proper subset. Let's start with just subset. We're going to look at, for these 4 examples, if A is a subset of B. Let's do subset in red. Okay, so the first example, we have set A, which contains the elements snow and sleet, and set B, which contains the elements snow, hail, rain, and sleet. 1, 2, there we go, separated. Okay, so for A to be a subset of B, all elements of A have to also be elements of B. So is that the case for this example? Are all elements of A, snow and sleet, also elements of B? The answer is yes, so this is a subset. The question here, is A a subset of B? And for the first one, it is. For the second one, set A contains the elements Q, S, A, and V. Set B contains the elements V, S, A, and Q. For it to be a subset, for A to be a subset of B, all elements of A have to also be elements of B. And again, in this case, they are. So A is again a subset of B. For number 3, we have this written in a different format. The first two are written in roster form. This third one is written in set builder notation. So we have all elements such that they're natural numbers and less than 7 for set A. And then set B contains all the elements that are natural numbers and less than or equal to 7. So let's get an idea of what that actually translates to. If they're natural numbers, remember that means counting numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, 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 on to infinity. They're natural numbers and less than 7, meets both criteria. That means the elements are actually 1, 2, 3, 4, 5, and 6. If we translate it to roster form. So this is set A. Then set B, if we make the translation, contains natural numbers that are less than or equal to 7. So set B contains 1, 2, 3, 4, 5, 6, and 7. And so the question is A, a subset of B. All elements of A are also elements of B. So again, the answer is yes. Don't remember what I was going to say there, but I think we're good on number 3. I know. You don't have to necessarily make the translation to roster form if you don't want to. For me, it's helpful. I like to see all of the elements, but it's not something you have to do if you don't feel like you need to. Okay, then number 4. So A is the set containing the Great Pyramid of Giza. So this is a description. And then B is the set containing all tourist attractions in Europe. So is A a subset of B? So that would mean, if it's a subset, that the Great Pyramid of Giza is a tourist attraction in Europe. Now, this type of question isn't something I would ever ask in a test because I can't assume that you know where the Great Pyramid of Giza is located, but it's something that we can definitely do in the videos because I can help you find the answer. So in fact, the Great Pyramid of Giza is not located in Europe, it's located in Africa, which means the Great Pyramid of Giza is not also an element that is a tourist attraction in Europe. So in this case, for number 4, the answer is no. Okay, so that's looking at specifically subset. Let's make the same analysis for a proper subset. Proper subset is almost the same definition. All elements of A are also elements of B, and the two sets are not equal to each other, so they don't contain exactly the same elements. Okay, so the first one, snow and sleet, is set A, and then set B, snow, hail, rain, and sleet. And so we're asking, is A proper subset of B? So are all elements of A also elements of B? The answer is yes. Second part, are they equal to each other? They're not equal, so this is a proper subset. This is a smaller grouping of those elements from set B. Second example, we have the elements Q, S, A, and V in set A, and V, S, A, and Q in set B. So in order to be a proper subset, it has to, all elements of A have to also be elements of B, and the two cannot be equal. And in this case, the two sets are equal, which means it doesn't fit both criteria, so it's not a proper subset. I think this is the best way to see the difference between the two. If we're comparing, is A a subset or proper subset of B? It can be a smaller grouping like it is for the first one. A smaller grouping counts as a subset and a proper subset. But if they're equal, it only can be a subset. Proper subset means a smaller grouping of them. Okay, the third one, we have the set builder translated into roster form, so we can make the decision from there. Are all elements of A also elements of B? Yes. And are the two equal to each other? They're not. Set A is a smaller grouping, so this again is yes. And then for the last one, we're looking for A to be a subset, a proper subset of B. First criteria is that all elements of A are also elements of B, and it's not. So automatically the answer is no. They're definitely not equal, but A doesn't even contain any elements that are in set B. So let's add one more note here on the distinction between the two. So you might notice the symbol for subset. This is subset. It looks pretty similar to a less than or equal to symbol. And this is definitely one way that you can think of subset. Are all the elements contained in there, and is it a smaller or equal group to what already exists? That would make it a subset. Compared to a proper subset, this is proper subset. This looks similar to the simply less than symbol. And you can imagine that proper subset is similar to less than in that it has to be a smaller grouping. It's not necessarily a comparison of how many or the exact number of elements. It's just looking at the elements themselves. Is it a smaller grouping? Then it's a proper subset. If it's a smaller or equal to grouping of the same elements, then it's a subset. All right, let's do a little bit more practice with these symbols. Okay, so there's three symbols we're going to look at here, and this is just using the two symbols in the right way. It's getting used to the notation because we're going to use it more throughout the chapter, and we're just going to use this as a true-false exercise. So there's three symbols that we're seeing throughout here. The first symbol, kind of the C with the line in it, remember this is an element of. Then we have the C with the line under it, which is our subset. And then the C without the line under it is our proper subset. So we talked a little bit more in detail about the difference between subset and proper subset, but I want to throw in the element symbol to make sure we understand the distinction between all three of them. Okay, so the first one, this translates to 3 is an element of the set containing 3, 4, 5. Is this true or false? So 3 is definitely one of the elements on that list, and we're using the element symbol. So this is true. The second one says the set containing 3 is an element of the set containing 3, 4, 5. For it to be an element in this list, we would need to see this exact item in the list, and we don't see it there, so this is false. The wrong symbol is used here. If it's in braces, then we're viewing it more as a set, and so we would have to use some sort of set symbol, subset or proper subset, to make a comparison. Then the next one, we have the set containing 3 is an element of the set containing 3, the set containing 4, the set containing 5. So the set itself, the big set on the right, contains a bunch of little sets. Those aren't necessarily subsets, it's just there are sets inside of there. And so this time, we do see this exact item in the list, so we can use the element symbol. You're not typically going to see the element symbol used this way. Typically, it'll be with one single item or a few different items, like the first one. So this one is true. The next one, we have the set containing 3 is a subset of the set containing 3, 4, 5. So are all the elements in this set also elements in this bigger set? The answer is yes, so this is true. One way to take the items in that set of 3, 4, 5 and hand them out is to hand out just 3. So this is one way to break that down. It's a subset. The next one says 3 is a subset of the set containing 3, 4, 5. In this case, we're using one of the set symbols, proper subset or subset, and what we have on the left here is not necessarily written as a set. This is listed as an element. So this one's false because the symbol is not correct. You could cross that out and fill in is an element of. 3 is an element of, but it's not. The item 3 is not a subset. For it to be a subset, it would have to be within those curly braces. Okay, the next one, the empty subset, or the null set, empty set or null set, is a subset of the set containing 3, 4, 5. So is one way to take the items 3, 4, and 5 and distribute them, is one way to distribute them to not hand out any of them. This is a little tricky. The answer is yes. So this is true. Well, it doesn't seem like this should be the case. Are all elements of this set also elements of this second one? You don't see a blank space there, but certainly the blank space exists. One way to hand out those 3 items is to not hand any of them out. That's a choice you have. All right, the next one. The set containing 3, 4, 5 is a subset of the set containing 3, 4, 5. For this one, we're looking at subset specifically. So for it to be a subset, all elements of the first set have to also be elements of this second set, and they are, so this is true. The next one, now we start to look at proper subset as a symbol. 3 is a proper subset of the set containing 3, 4, 5. 3 in this case is not in braces, so we can't really think of it as a subset or proper subset. We have to kind of view it as an element, so the symbol would have to follow. So this one is false. If you wanted to correct it, you could instead put the element symbol in there. Or another way, maybe you could put a slash through it. That would be right. 3 is not a subset of the set containing 3, 4, 5. And then the last one here, the set containing 3, 4, 5 is a proper subset of the set containing 3, 4, 5. So 2 criteria. First, are all elements of the first set also elements of the second set? They are. And the second criteria is that they're not equal to each other. These are equal to each other, so this is false. Remember, for it to be a proper subset, it has to be a smaller grouping of the items. So we couldn't have all of them 3, 4, 5. If there were just a few, it would work. And in fact, you could correct this to have it be subset. It is a subset, but it's not a proper subset. Subset can be smaller or exactly the same. Proper subset has to be smaller grouping. Okay. That's one way to correct it. All right, so hopefully you've got a better idea of how to distinguish between those 2 symbols. So let's move on to that next objective then. The next objective is looking at the number of subsets. So we're going to list the distinct subsets for the given example sets. Okay, so the first one, let's say that we have 0 elements. As an example, the set could be the empty set. So if this is the set, let's list all the different ways we could deal with all the items inside of there. So there are no items inside of there. How many different ways can we hand them out? There's only one option, and it is to hand none of them out. So for the number of subsets, let's go with red. We have 1. If there are no elements in the set, there's only one subset that exists. Okay, how about the second one? Let's say we have 1 element in the set. An example of that could be having the set containing A. Let's list all the subsets. What we're listing here are subsets. So if we have 1 item, how many different ways can we distribute that item? We can distribute the item, we can give it away, or we can not give it away. So in this case, there are 2 subsets. Okay, the third scenario, let's say we have 2. The set containing A, B. Let's list all those subsets. So there's 2 items. How many different ways could we choose to hand out the 2 items? We could choose to hand out both of them. We could choose to hand out just one of them, and it could be A, or it could be B. And we could choose to hand out none of them. So if there are 2 elements in the set, then we have 4 different subsets. You might be wondering, is it the same to say B first and then A? Remember that the elements, the order that you list the elements doesn't necessarily matter. So it's the same thing to say BA or AB. It's just a matter of listing all the different options. All right, let's go with yellow. Okay, then the last scenario is that we have 3 elements. So let's say we have the set containing A, B, C as an example. And then what are all the different ways we could choose to hand out the 3 items? We could hand out all 3. We could hand out 2 of them, and the 2 could be AB. It could be BC. It could be AC. We could choose to hand out just 1, and it could be A. It could be B. Or it could be C. And we could choose to hand out none of them, which gives us a total of 8 options. So you can see a pattern emerging here, potentially. We're kind of looking at 2 objectives here at once. So when we're, the one on the right, where we're listing all this stuff, that is listing subsets. Being able to look at the list of elements that you have and then list all the different ways that you could imagine handing them out. So if there's 2 of them, you could hand out both, you can hand out just 1, or you can hand out none of them. If there's 3, you could hand out all 3. You could hand out the first 2, or the last 2, or the first and the last. You could hand out just 1 of them, and it could be any of the 3. Or you could hand out none of them. So one objective is being able to list them. Another is being able to decide how many subsets a given set has. Sometimes we don't necessarily care what exactly each subset looks like, but we want to know how many there would be. How many different ways could we do something? So based on this chart, filling this in, what do you think the next thing would be? How many distinct subsets do you think you would get from a set with 4 elements? The first one had 1. Then if there was 1 element, we had 2. If there was another element, we had 4. If there was another, we had 8. There's a specific pattern there, and the pattern is multiplying by 2 every time. So if we had 3 with 8, then when we have 4 elements, we would have 16. And it's because it multiplies by 2. Let's fix that. Multiplies by 2. And if you don't trust that, you can definitely go through, make an example for yourself, and then try to list all the different subsets. It gets really difficult to list them all, the more elements that you have. As you can see, the number jumps pretty quickly. So you can imagine if you had a set with 5 elements, it would have 32 subsets, and so on. So even once you get to 5, already there's 32 different things you'd have to list, and that's a lot. So what we're going to do next is decide how many, kind of come up with a formula for figuring this out. So the first one, the number of distinct subsets, we saw what the pattern is. The pattern is multiplying by 2 over and over. Repeated multiplication is an exponent. So the number of distinct subsets of a set where n is the number of elements is 2 to the n. So you can plug this in and check to see that the previous problems we just did fit that model, and they definitely do. The first scenario is that there were no elements. 2 to the 0 power, anything to the 0 is 1. Second scenario, 1 element. 2 to the first power is 2 subsets. Third scenario, when we had 2 subsets, 2 to the second is 4. There were 4 different subsets, and so on. So this is one formula. Okay, so that's one. The other formula that we're going to come up with is for the number of distinct proper subsets. Remember, the only difference between subset and proper subset, a subset can be any grouping, including all items. A proper subset can be any of those groupings except the one that is all items. So this definition, the number of distinct proper subsets of a set where n is the number of elements it's 2 to the n minus 1. You just have to subtract out the one subset that contains all of them that doesn't get considered a proper subset. Not very many formulas at all in this chapter, I promise. And these aren't too complicated, but these are some formulas that can help you figure out how many. Now, if you get to a problem where you're asked how many distinct subsets or proper subsets are there, and you don't remember the formula, you can always list them and then count. But this is going to be much faster if you have a set that contains a lot of elements. All right. So let's just do a quick little bit of practice. How many distinct subsets are there if the set contains 6 elements, and then how many distinct proper subsets? You can pause the video, fill these two out, and then we'll come back together and go through them in a moment. Okay, so the first question, how many distinct subsets are there if the set contains 6 elements? 6 elements, according to the formula, means our n is 6, and the formula is 2 to the n. So we have 2 to the 6. This is how many subsets there are. 2 to the 6 just means repeated multiplication. You can do this in the calculator, by hand, it doesn't matter. Each of the 2's multiply as a pair to get 4. 16 times 4. 64. Just as you saw in the pattern, we saw that 5 elements had 32, times 2 is 64 to your next one. So that definitely works as well. And then how many distinct proper subsets? That formula is 2 to the n, whoops, not minus 1 up there, minus 1. So we have 2 to the 6th minus 1, which is 64, minus 1, so 63. The only difference for a proper subset, it's any of those smaller groupings, just not the grouping that is all items. So if there's 6 pieces of candy, you're trying to decide how to hand them all out, how to potentially hand them all out. There are 64 different ways. If you want to do any handing out, but you just don't want to hand them all out, then there are 63 different ways. Okay. So in this video, we looked at subsets. We saw the difference between proper subset and subset. And then we also did a little work with notations and an exercise. I will see you soon for another video.